them off. They've decided to stay home. They're afraid of what the highways are going to turn into in an hour, which might be reasonable. But anyhow, we're here, so we're going to talk about this. The article that I asked you to read for today, Article 1, was written by Sierrocco, Lewandowski, and Van Volkum. And by the end of the semester, you are going to know this article upside down, sideways, backwards, frontwards, every other words. Because your final paper in this class will be a comparison of this research study and another research study that we're going to read later in the term. So if you took the time to read this article and go through this article worksheet and the time to be here today, it's going to be to your advantage because you're going to need information from this lecture today, from this discussion. Actually, I'm not lecturing. You guys are telling me stuff. From this discussion today for that final paper. So if there are things about this study that you don't understand, you want to make sure that you get them clarified so that you will have what you need in terms of details and data to work on that final paper. So let's go ahead and get started. Everybody should have their worksheet out. You should have submitted a copy online with your answers, what you thought the right answers were. You don't get scored for accuracy, you get scored for effort on these assignments. This is an issue of preparation. Did you take the time to try and answer the questions? Did you take the time to try and read through the article? Did you figure out the parts that you had trouble with so that when you came here today you could ask questions about things you didn't get? And that way you get more out of what we're talking about and you're ready to focus on the things that you need, not just on everything because you hadn't looked at it yet. Okay, so the first question says the primary hypothesis tested in this study was that the multifaceted approach would improve students' impressions of research design and statistics. That was the hypothesis they were testing. So what's the independent variable? Yes?
Instructional methods of the teacher.
Okay, instructional method, good. Okay. And what's level 1? That would be the experimental condition? Yeah? You can answer the whole question. Go for it.
Multifaceted.
The multifaceted approach. Okay, good. And the other was the traditional approach. Right. Okay, good. Perfectly good. So so we're talking about instructional style. And the experimental condition was the multifaceted approach. The control condition was the traditional approach. Now, here I'm going to ask you a question that's not on the sheet, because you should be able to answer this based on what we've been doing in class over the past week or so. Given this alternate hypothesis, right? That's an alternate hypothesis because it's not a null hypothesis, right? Should they be doing one-tailed tests or two-tailed tests? The multifaceted approach will improve students' impressions. That's a directional prediction. So they should be doing one-tailed tests because it says it will improve. They're making a specific prediction about the direction of the effect. They're saying that students in the multifaceted condition, in the experimental condition, will have improved scores relative to those in the control condition. So you should be able to spot that. That's the kind of clue that improve students' impressions. That's the kind of clue that should trigger that's a directional prediction. That's a one-tailed test kind of thing. Okay. Now it says, they talk about the multifaceted approach and the traditional approach. What is the multifaceted approach? What does that mean? What does it include? Yes, expert of the day.
This is the last one.
That's what I will take. You know what? Go for the early ones, because at the end you're like, I did like the first page. I don't know what you guys are doing, but yeah.
The multifaceted approach uses scaffolding.
Scaffolding, okay.
And they were more hands-on, whereas like the traditional, they read assignments from the book or lecture.
Okay, so the traditional approach was read a chapter, go to class, listen to a lecture, talk about examples, take a test. That's the traditional approach, right? The other approach had scaffolding and hands-on learning techniques. What the heck is scaffolding? That sounds like something you used to paint a building. What's scaffolding? Yeah.
I think it was, the professor gave the students more and more independence throughout the course.
Right, so when we talk about scaffolding in a instructional context, we're talking about how much guidance and structure the instructor gives the students. So in the beginning, students who don't know what they're doing need a lot of scaffolding, right? Do this, okay, now do this, okay, now do this, okay, now do this. Kind of like, a handout where you list every step you do in a statistical analysis, right? Okay, now do this, okay, now do this, right? In the beginning, you need that kind of structure so that you can figure out what it is you need to do. Over time, as you get better at it, the instructor then withdraws that extra support, that scaffolding, so that the student can become more independent in being able to solve the problems on his own or her own. Right? So scaffolding is it's the overt structure that students can use to kind of build their knowledge on, so that then eventually the teacher can move away and you've got a structure of your own. You don't need me to tell you what to do. You get what you need to do because you've done it. You've built your own structure with my knowledge. That's the idea. So that's scaffolding. And then what was involved in these hands-on activities? What kinds of things did they do? Yeah.
They had an in-class demonstration.
Okay, so they did a demonstration in class. What was that about? What kind of demonstration?
They
They did an experiment in class where who were the subjects? The students were the subjects, right? So the professor was the researcher. Okay, so they did an experiment. The students were the subjects. Okay. Then what?
They also did an article where he was more hands-on as far as walking them step by step.
They did an article. What do you mean?
Well, did an article critique.
They did an article critique. Okay.
And then they analyzed their data.
Okay, they analyzed. So there's I think you're getting two things mixed up there. By the way, you keep saying he for the professor. Note that two of these are women, so chances are it was she who led them through. Just so you know.
How you know that?
Because it says Natalie, Gary, and Michelle. I'm just guessing, but I'm thinking anyway. So just don't want presume that the professor was a man. Why would you do that in here? Not in here. All right. Anyway, so they had to read an article, right? What did they do with the article? They read the article, and it was about the kind of design they were talking about. Okay, then what did they do?
They answered specific questions.
They had to answer very specific questions about it, summarize, maybe do some critique of it, right? And it was super scaffolded, right? So the instructor is saying, so tell me about the variables. Tell me about this. Tell me about that. So kind of guiding them through how to think about the article. So very organized, right? Very structured that they're thinking about it. Then they do the demonstration in class where they get to participate. And they talk about how that went. And then what happens?
And they did
small groups.
Then they break off into small groups. And what do?
They mimic research process.
Okay, what does that mean?
They did something similar to the in-class demonstration.
Okay, so they do something similar to the in-class demonstration, answering certain questions, but are they being told exactly what they need to do?
No.
No, now they're getting to try to come up with their own ideas, fix their own stuff, okay, gather their own data, and then what happens?
However, they were given a general research question.
Right. They're not just thrown to the wolves. I mean, they're brand new at this. Yeah. They get a general research question, okay, then they get to try and gather data,
Create a plan.
Enter their data, analyze.
do analysis,
Do a APA.
write it up. Okay, so notice that in that multifaceted approach, there's no discussion in there of the professor lecturing, right? That learning is happening by reading articles and doing stuff. There's not a lecture component. We're going to talk about these things in terms of doing it. Okay, so that's the interactive scaffolding approach, and the relevant concepts get introduced in that process. So we've discussed several different kinds of control conditions in class. What kind of control conditions did the researchers use in this study, and how do you know? Expert back there, she's holding back. She's doing her, she's reaching, she's looking at me for a clue. Should she stick? Oh, it's hair. Come on, what kind of control condition did we have? We've already given you a bunch of hints. What kind of control conditions have we talked about? No treatment control, standard treatment control, waitlist control, placebo control. What kind?
Standard treatment control.
Standard treatment control. How do you know?
Because the first group had just regular class.
Just the typical class, right? It's not a no treatment control for sure. Because you can't have people come to class and not teach them anything. That's not cool. We're going to give you a test. We're going to ask you how you feel about research methods and statistics, but we're not going to teach you anything about it, so you won't have any idea. That doesn't make any sense. So you got to teach them, but they're going to teach them in a standard way and compare that to the new innovative, super hands-on, scaffolding, multifaceted approach, whatever that is. Okay?
I have a question. If you
Okay.
were to put
That's why we're here.
number 1C, if you were to put they had a comparison group as a control for the condition, would that be correct?
Well, controls are always comparison groups.
Okay.
So that's always true.
Okay.
So this is a particular type of comparison group. It's a
Okay.
standard treatment control comparison
So you
group.
have to elaborate on
Yes.
that?
Yeah, because it's always, controls are always a comparison group.
Okay.
But this is a particular type of control, a standard treatment control. Another way to think about these two conditions, we can think of the experimental group as the active learning condition, because they're doing what we call active learning, where you're learning by interacting with the concepts, I mean literally getting up and doing something with them, as compared to the more traditional approach, which is more passive. So we talk about passive learning, where you sit there and the professor goes blah, 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 you write it down, it goes in your head, right? Where you're not engaging, interacting with the material in any way. You're not trying to think about it, you're just memorize, regurgitate, memorize, regurgitate, memorize, regurgitate kind of stuff. Is the IV described here a between subjects or within subjects variable? Okay, how do you know?
Because neither one of the groups were like switched to where they had to retake the class and take the lecture in the chapters, or the other one having to do the active learning.
Okay, so they either did active learning or they did passive learning, but they didn't do both, right? So we have one group of students was in the control group, another group of students was in the experimental group. Those are separate groups of students, right? They even were separate semesters, right? Control group was in the spring, experimental group was in the fall. So separate, totally separate groups, independent of each other. Okay, so that's between subjects. Yes. Okay. Is it a manipulated variable or a subject variable?
Subject.
Okay, we have a vote for subject. We have a vote for manipulated.
Yeah, I said manipulated too.
Okay, so tell me why. What's your reasoning?
I said subject because the students were selected from like a 3-section.
Were they randomly assigned to the conditions? Did the researchers get to choose who was in their sections?
I mean, they picked from fall and spring.
Yeah, they picked that, but were they randomly assigned? Did they get to randomly assign when subjects take the class?
They weren't randomly.
Do they really get to manipulate? No, there's not a manipulation here. This is a subject variable. The subjects were selected because they were taking the class in the semester they decided to gather data. This is a subject variable. The subjects had a pre-existing state of being enrolled in the class.
So I was thinking, as far as
Good. That's what we want. Thinking is
I
good.
was thinking, as far as that particular question, when they were talking about the independent variable, not as far as the participants, but as far as what was being, like the teaching approaches as being manipulated. That's
Well,
why I picked the manipulated variable.
So do you think the
not
teaching
subject.
approach, do you think that they could, I mean, so you're thinking, did they randomly assign whether they did one in spring and one in
Well, I know there was no randomization as far as the participants, period.
Right, there's no randomization of, so in order for something to be manipulated, it has to be possible to randomly assign the subjects to the conditions that they experience.
Okay, so.
Or you have to be able to randomize the order in which they experience the conditions. So, for it to be truly manipulated. You have to be able to randomly assign the subjects to the conditions. So every subject has an equal chance of being in any condition. So you have to have random assignment, or you have to be able to randomize the order through some kind of counterbalancing. And they could not randomly assign the subjects to take the class in a given semester. They could have certainly switched, they could have done something else where they ran, they could have switched it, they could have done the experimental group first and the control group second, but it's not clear that that's any better than control group first, experimental group second. In fact, it's probably harder to do it that way, because it would be harder to teach it the new way and then go back to the old way. So the issue with something being manipulated is you have to be able to randomly assign the subjects to the conditions, or you have to be able to randomize the order in which they experience the conditions. And that's not possible here. At least they didn't do it, right? They didn't do it as a 10 subjects design, because nobody took the class more than once. So I would argue this is a subject variable, because the subjects were assigned to the conditions by their personal choice, and whatever they signed up for. Right? They made their choice based on when they had taken the prerequisites, what their other course demands were, whatever other things guided them. So which section they were in was about them, not about the power or the choice of the researchers. They didn't have control over who signed up in fall and who signed up in spring. Does that make sense? They just picked them because they happened to be there at the time. So they were selected for convenience, not because they were randomly assigned to those conditions. Does that make sense? That's a tough question, but it's an important issue for this kind of study. In these kinds of studies where we look at how to make teaching more effective and trying to study different ways to teach more effectively, we don't get to randomly assign. In fact, that was a question later on down the road, right, in the handout. I asked you at the end. It says, they talk about one of the limitations of the study being that they couldn't do random assignment. Why can't you randomly assign subjects in a situation like this? What would the consequences be? Why can't I just say, okay, all majors have to take 3530, so I'm going to randomly assign you to take it this semester, and I'm going to randomly assign you to take it this semester? Why can't I do that? It's for science! We're a science major, it's totally fine. What are the problems with that choice? This answers a question later on. We don't have to do them in order, so what are the problems with doing that? You're like, oh, that was at the end of the handout. I didn't get that. No. I mean, why not?
I feel like it'll skew your data.
Why?
Because it's not real world. The people who will be doing this kind of stuff are psychology people.
Yeah, but it actually would improve my internal validity. But it would jeopardize my external validity, right? It's always a payoff, right? There's always, you've got to pay. When you increase internal validity, you typically reduce external validity. There's always a cost. But what are the costs? I mean, think about what the implications could be for the students. How much thought did you put into which section of this class you took and when you took it?
Well, I mean, for a consequence, you could be adding on an extra class for somebody that's like a business major.
Well, but they're all psych majors. Only psych majors have to take this class. So how would you feel if we randomly assign you to take a class with a particular professor in a particular semester?
No, I said no.
Well, okay, well, but what if I'm saying you don't get to? Why? Why would that bother you? What do you care?
Because I'm choosing my life. And
You're choosing your life. Well, what does that mean? Why should you get to choose that?
Fit my schedule.
Okay, so you have your own schedule demands, right? So if I randomly assign you, that could, what if I assign you to a class that conflicts with another class you have to take? Or I assign you to a class that conflicts with your work schedule? Or your child's daycare schedule? Or whatever other things, other demands you have in your life? Okay, what else? What other things influence why you take a course? Oh, come on, ratemyprofessor.com. You know it, right? You want to be able to pick. You want to have some choice. You want to be able to find out if there's somebody who you think you would like or you wouldn't like. Maybe it's a class with somebody who, maybe you have had a friend who took a class with that person and you're taking it on their recommendation. You want it to be a good fit between you and the professor, right? You want it to be somebody you think you will enjoy learning from, learning with, not somebody who's got a reputation for being mean or unreasonable or, having ridiculous grading standards or whatever else, right? You want to have some choice because you might get along with certain kinds of professors better than other kinds, right? You might like certain kinds of testing better than other kinds, certain kinds of teaching better than other kinds. And you know what those things might be. And if I just randomly assign you, I could match you up with, haven't you all had a professor who was just like a terrible match for you? Right? Sometimes it doesn't work, right? So, it's randomly assigning students could be a problem. What happens if they don't do well in the course because the match isn't good or because they can't come to class? And can you please put your phone away, please, please, please? Thank you. It's really distracting. ADD is a curse. Anyway. And I have it. I can't concentrate. I'm like, wait, now I'm all distracted. Okay, so, what would happen? Say you're in a class that conflicts with your schedule so you can't come very often. Or you have a class with a teacher you can't stand.
It affects your grade.
It's going to affect your grade, right? And who's paying for this? You! Right? So here's the idea. So here's a class you're paying tuition for. Somebody is. Hope Scholarship. Somebody's paying. Parents, grandparents, somebody, right? Somebody's coughing up money for this class. And I'm going to randomly assign you to a time and a teacher that you have no control over. And you have to pass this class or you can't graduate. What's that about, right? Think about the implications of that. That could have negative implications for a student's GPA, negative implications for their budget, right? Maybe they'll get assigned to a great teacher in a great class and they'll love it, but if you randomly assign them for the purposes of research and it doesn't work for them, then what are you going to do to fix it, right? Because that could keep them from graduating, right? It could put them behind in their graduation, could affect their GPA. If they get a really bad grade and it messes up their scholarship eligibility, really? Is science that important that it's okay to do that to students? No. That seems like it would be ethically really problematic, which is why in these kinds of studies, we don't get to randomly assign students because we're trying to get as much real-world effect as we can. We want external validity in this case. More critically, we want something called ecological validity. Which means we want it to be as much like the real world as possible. And in the real world, students pick their teachers. And in the real world, students pick their schedule. And so if I want to find out what kind of teaching strategies work well, then I should be dealing with as realistic a student group as possible. And everybody who would take this class at this time on this day, well, yeah, you might be different from students who would choose to take it at night. Right? We do offer this class at night. We have students who take it on Monday, Wednesday, or Tuesday, Thursday, and their class starts at, they have class from like 7 to, from 5 to 6:45 or something, and then they have lab from 7 to 9, because they work all day and they come and take class at night. That's going to be a different group of students than you guys who are taking classes in the middle of the day. So these classes are different. They're made up of different students. But that's the reality. That's how it works. Right? That's what the classroom is really like. So if we're going to teach in this situation, I would rather try new teaching strategies in a more realistic teaching setting than in one that had been artificially created and could potentially cause a lot of problems. That could be a real mess. And ethically, real problem. Okay. So the greatest challenge of performing a study on independent groups is making sure the groups are similar enough to compare in a meaningful way before the experiment begins. So I asked you to take a look at the descriptive statistics for the groups that are provided in the paper and tell me what you think about how the researchers did at forming comparable groups, given that they had to select their students, not assign them. How'd they do? What do you think? Yes?
I said that we don't know like the age in class groups are comparable, but we do know there's no difference between semesters based on age in class.
Yeah, so we.
The descriptive said something about whether students were in lab or not, but they were.
Okay, so they did compare them. They gathered data about their age and about what year they were in school, and they found that there was no difference in the age for the two groups, right? And there was no difference in the year in school. So in general, they were both about, on average, 22 years old. And they were on average somewhere between being juniors and seniors for the most part. So they were about the same in those ways. They did say that they asked about whether or not they were in a lab. I think there was, but they didn't indicate whether there was any difference between the two groups. So you're right about that. They said they asked that data. They asked about that, but they didn't actually crunch those numbers, I don't think. Anything else? What other similarities? Anything else in there? Anything else about descriptive statistics or inferential statistics that was helpful?
I believe they said something about the males did better one semester than the other.
It's not that they did better, it's that there were proportionally more males in the control semester than there were in the experimental semester. There were more males. However, in both cases, females were the majority. So there were always more women. But there were more males proportionally in spring than in fall. So they differed slightly in terms of the proportion of males to females, but across the board there were more females both semesters. And if we think about, okay, let's take a look in this room, let's look around. Does this surprise us? No. In psychology, classes are disproportionately female because it's a profession that's about caring for others. And our society says caring for others is a girl thing to do. Or a very strong man thing to do. Because if you're a guy who can care about others, you must be really confident in your manliness. Right? You can care without it threatening your total bossness. Right? So that's why there are fewer, there are more women in this field. So that's typical for psychology majors. Okay. So in the procedures section, it indicates that the students in the control group were tested in spring, while students in the experimental group were tested in the fall. What kinds of third variables might this difference in timing introduce to the study? Is there anything the researchers could do to manage these differences and their potential threat to the study's internal validity? So how are people who take a class in the spring different than people who take a class in the fall? Yeah.
Okay, so as far as them taking it in the spring versus the fall, some of the information can leak. I said leak to the people that's taking it in the fall semester.
Well, it's not a secret. This is a required class.
Well, as far as how they're being tested, before I read the next following questions when I saw that there was only 30 professors that were involved. I was saying that that could skew their data as far as that may be a third variable.
Okay, so students in the control semester might be more naive about the course.
Right, or they may have a bias of what might go on with that specific.
Right. Well, if those students in the spring asked anybody, so what's this class like? And everybody says, oh, you take a lecture, you read a book, you go to lecture, and they would have gotten good information.
Right.
People in the fall, if they asked anybody, what's this class like? Everybody says, oh, well, you read a book, you go to lecture, you take a test, they come in and it's totally different.
Right.
So that might make them be like, whoa, this class is totally different than what I was expecting. Right. Not awesome. Okay, that's one thing. Yes, you had your hand up.
The amount of time before, like during the break, like when a break's really short, summer's really long, so that's the amount of time like they don't spend like being as busy, I guess, and not being used to being as busy.
Okay, yeah, so students who take a class in the spring, they they've been in school since fall, right? Then maybe had winter break for a couple weeks, and they come right back in. So they're kind of in school mode. Whereas fall, it takes a little while to ramp up because you've been like, summer, right? Now I'm like, oh man, here we are back in school again. Ugh. Unless you're like lots of Georgia State students, apparently, you just keep taking classes all summer because you're like, just get me out of here. Right? But yeah, so that's another issue, is how much of a time have they had since they took another set of classes? Also, well, go ahead. We'll see if we get to it.
If you do the prereq class, 30
whatever
before, versus they would have done it fall semester 2008 and then went straight into 35-30, so it's a little bit more practice.
Right.
Versus the experimental group who, with the time, was out of school for a couple months and they came right back.
Right. So how many of you took 3510 last semester? Yeah. Right. So chances are that many of the people in the spring group took the prerequisite immediately before, with only a short winter break in between, whereas the people in the fall semester probably took the prerequisite the previous spring, which means they had the whole summer to forget everything. So they might be like, what are you talking about? I don't remember any of this stuff. Okay. So these are ways that they could be different. What about, you guys ever get spring fever?
Sure.
What happens in spring semester? Is it harder to concentrate on your classes because you're like, summer's coming! Woo-hoo, I'm so sick of doing all this stuff. I'm going to burn out. I don't care anymore. And then in fall, you're like, all right, the weather sucks. It's horrible. There's nothing fun to do. I'm just going to work. Right? Just get it done. Get to the holidays. Okay? Get it done. So it could be that, one semester people tend to be more focused than another semester. That's possible too. Most of the things we've identified are things that should put the experimental group at a disadvantage, right? So it's been longer since they took the prerequisite. It's been longer since they were actively involved in school. The way that the course is being taught is very different from how it's been taught in previous semesters, so they're the most likely to be surprised by what's happening. So all of these things should put the experimental group at a disadvantage, making it less likely that students would do well. Making it less likely that they would respond positively to the situation. If you're going to have problems, that's the kind of problem you want to have. It's the kind of problem that should challenge the hypothesis you're making. Because that way nobody can say, you skewed the data in your favor. You made it so that the students in the experimental condition would like it better automatically. You made it easier for them. In fact, it seems that they actually set it up so that it would be more challenging for those students. So if they were going to dislike the course or not do as well because of the amount of time it had been since they'd taken the prerequisite or amount of time since they'd been in regular semester of school or whatever, it should have hurt their findings. And that's the if you're going to have to make a trade-off like that, you want to make a trade-off that will ultimately result in your getting no difference between your groups, not one that would bias the outcome in your favor. Because then people will go, observer bias, you set it up so that you would, confirmation bias, you're looking for your answer, right? So if they had to make a choice, this actually wasn't a bad choice to make. But it's still, there's still some concern about that. But, it's hard. You hear they've got 3 professors, right, teaching these classes. They've got 3 sections each semester, 3 professors teaching in the first semester, 2 of them teaching again in the subsequent semester. And what do you think the issues with that might be? And do you think that would have caused problems? That it wasn't exactly the same instructional team? Does that concern you? At least it's the same people. Oh, go ahead. Oh, what?
Well, I was going to say that I put that it did because somebody could be like more of an expert at one thing, and another one could just be like a lazy teacher, and they could just be totally different. And
It could be. So it could be that maybe the teacher who was in the control group that didn't participate in the experimental group wasn't as good. Right? That's possible. Was less enthusiastic about it. And teacher enthusiasm matters, doesn't it? I mean, if I sat up here...
That's how I'm looking at my desk.
So, tell me about the article. You guys, you've had professors like that, haven't you?
Yeah.
Yeah. And it's not very much fun, is it?
No.
It's hard to get excited about the material at all, right? If you got somebody who's kind of crazy and jumping around and stuff like that, yeah, does interpretive dance or, whatever. I'm not dance. It's not happening. But, so it could be that there was some issue, right? That could be a problem. It depends on how good that teacher was. We don't have any information about like teacher evaluations or anything to know how good the teachers were who were in both semesters. We're not sure. We don't have any information about how much the students learned. None of their dependent variables have anything to do with how much the students learned in either semester, so we don't know if they learned better in one semester or the other either. So this could be a potential concern. It's a problem. So how could they have addressed these issues? What could they do to fix these problems that would have made this conditions more similar? Because they're just introducing differences. Yes?
I said if they had 3 different professors to teach all 3 sections separately, fall and spring.
Okay, so they could have 3 professors in the fall and 3 professors in the spring in the same 3.
Yeah.
Right, so they get the same professors to teach both semesters. That would help. Okay. The downside, the thing there is that, did you know that we don't get to pick? We get to ask, we say, here are the classes that I'm willing to teach, that I can teach, that I'm qualified to teach. And then we get assigned to teach whatever they give us. So I can give them a list, and typically they'll assign you to teach what you're good at, right? Because they've got people who are good at teaching different things, so they'll let you teach. And the more seniority you have, the more likely you are to get to teach what you ask for, because you've earned it, right? You've earned the right to get to pick, for the most part. But if in a given semester, what happens if the person in the control group who didn't come back, what if that was a woman who was pregnant, she was on maternity leave during the fall, so she couldn't? We say, I'm sorry, don't have your baby this semester for science. Right? I don't know. So maybe she's a great teacher, but she just had a baby that semester or something. I don't know. So stuff happens, right? Sometimes you don't get to choose. So if you do it over 2 semesters, you might have less control over making sure that the assignments were the same. It might take a little bit more work to make that happen, but it's possible. So that's one thing we could do, but it would take some more negotiation with the chair of the department, stuff like that. Yeah?
I was thinking that they can do both a control group and experimental group in the same semester. Like,
Okay.
different teachers do a control group versus an experimental group.
Okay, so they could have one group of teachers teach the experimental way and one group of teachers teach the control way. Now that means are you talking about having different teachers?
You can either, yes.
Okay, so if you have different teachers, that means we've introduced a potential confound, because then the instructor is varying with instructional approach also.
Or,
But isn't that one of the limitations that they had already presented in the discussion, that they weren't able to get rid of?
Well, it's a challenge because they couldn't keep it exactly the same, right? One of the reasons that they did it over 2 semesters was because that way the same people could be involved as much as possible. But I can say that as a teacher, it would be very difficult to teach. So one thing we might do then is say, okay, what if we have each teacher who's involved in the study teach one section one way and another section another way. Okay. So like you guys know right now, I teach this section right now, and then I walk across the hall and teach it again. So what if I was teaching this class in the traditional lecture way, and then I walked across the hall and did the other one in a different way? Now, that's certainly possible, but let me tell you how hard it would be to teach like that. It's really hard to teach the same class 2 different ways in the same semester. It'd be like asking you to do your job 2 totally different ways in the same shift, right? I want you to come in and do your job. For the first 4 hours, I want you to do it this way. And on the second, the way you normally do it. And the second 4 hours, I want you to do it on one leg, hopping backwards, while you sing top 42s or something. You'd be like, okay, and then now you have to go back to doing it the normal way. Now you got to go back and do it the other way. And it makes, maybe it would make the job a lot more fun to do it the other way, but it still could be really challenging. So that could introduce, I think you might get some bleed over, right, where some of the interactive stuff might bleed over into the more traditional format. Some of the traditional stuff might bleed over. Because if I had expected you guys to all have read a chapter, and then I come talk to you, and then I walk across the hall, they haven't read any chapter, they've read an article, and I'm supposed to help them understand this, I'm thinking about it in a completely different way. So that's going to be tricky. It's going to be hard for me to make that shift. So it could work, but it would be pretty challenging. Also think, they had 3 teachers, and their samples for each condition were in the low 30s. That means that each section of the class they're teaching has about 10 students, 10 or 12 students. They might not have enough students in a given semester at this school to teach 6 sections in parallel. It's not like Georgia State, where we're teaching, like 12 sections of this class with 25 students each in each section. If the school's not big enough, they might not have enough students in any given semester that could participate. So that's another possible issue. So they might have to reduce it down to maybe just 2 teachers teaching 2 classes or something like that. That would work. So yeah, we could try some different things. Each one of those choices is going to have different costs. Right? They're all going to, if we do it all the same semester, it's going to make it harder on the teachers. If we do it in different semesters, might make it more challenging for the students because of the delay in between. There's always costs and benefits. Okay. The dependent variable in this study focused on students' perceptions and attitudes regarding research methods, statistics, and scientific writing. What kinds of instruments are used to gather data on the dependent variable? Survey questions. Okay. Good. What evidence do we have that these are good instruments to use? How do we know these questions are any good? How do we know the questions aren't junk? How do we know they actually measure what they say they're measuring?
Other than them giving examples of the question that was mentioned.
Okay, so they gave us examples,
Right.
and the examples seem reasonable. I mean, you're looking at them, they're asking, yeah? They didn't jump out at you like they were asking anything weird?
No.
Let's take a look. What do they say? They say, zoom in a little bit. Zoom in a lot, I guess. Zoom out a little bit. Okay, so they say that perceptions of research and statistics. This measure assesses various attitudes towards both research methods and statistics by asking participants to rate their level of agreement with 30 positively and negatively keyed statements on a 7-point scale. From 1 equals strongly disagree to 7 equals strongly agree. There's a couple things here that jump out at me. First, they talk about there are 30 statements. So they're asking 30 questions. They've got 6 subscales. Right? So that means if they've got 6 subscales, right, 6 things they're asking about, 6 different things they're asking about 5 questions for each thing. So they're not just asking 1 question for each thing, that's good. They're asking multiple questions to tap into each attitude, right? So when they're asking, for example, about how important do you think it is to know about research methods, they asked 5 questions related to that topic, not just 1. That's good. They also did positively and negatively keyed statements. That means that they set up some questions so people who liked the class would say 7, and some questions where people who liked the class would say 1. So they set it up so that nobody could just walk in and go 77777777777. And I'm sure everybody has filled out a survey like that at some point, where you're like, oh, I have to fill this out, I don't care, just mark them all the same. Make a picture, make a diagram, whatever, write a smiley face. So they set it up so that they would be able to check. Did the person who said 7 here say 1 here? The person with the same opinion should have marked 7 here and 1 here to make sure people were really answering the questions in an honest way. And that's important when you're asking people about attitudes and beliefs, because attitudes and beliefs are a very squishy thing to ask about, and people lie. And we're talking about a survey that was administered during class by the TA, right? And it's entirely reasonable that the students could think that their answers, even though they're told their answers are anonymous. Have you ever wondered if your student evaluations of instructor are really anonymous, or if we know? Is there a way for us to tell who wrote what? Well, when it's done online, it seems a little bit more secure, but back in the day when people used to have to fill them out by hand, I know students who would try to disguise their handwriting, or they didn't want to write any comments because they're like, the teacher's going to know who this is because they know my handwriting. And I don't want them to know that I'm the one saying, you suck. Any bum off the street could teach this class better than Dr. Darnell. I can't believe that Georgia State University pays her to do this. That was one of my first semester teaching. I'm like, serious? Yeah. Any bum off the street could teach this class better. Yes.
For real?
For real. Any bum off the street could teach this class better than Dr. Darnell. I can't believe Georgia State University paid. Of course, that's the one I remember.
Female or male?
No, this is actually handwritten on the comments. This is because I've been here for more than 15 years. Yeah, my guess is they got a D.
And they were pissed.
And they're pissed. So they're like, you suck. The student who writes, I came to class every day and got an F. F students don't come to class. I'm like, F students don't pass the tests. Right? You can come to class all you want, but if you don't learn anything, I can't help you, right? I can only do so much. Anyhow. So you can imagine that students might not be answering honestly under those circumstances. They might think that their grade in the course is dependent on how they respond. Right? There could be some subject reactivity. I mean, when you do teaching evaluations, also, if you thought the professor might know who said what, aren't you more likely to be nice? Just hoping it might help under some circumstances? So, they did negatively and positively key it, which is handy, so that they can double check to see if people are being honest. That's good. There's another thing in here that's good. Okay? They're asking about beliefs. They're using an appropriate scale. I mean, if you're going to ask somebody about whether they believe something or whether they have a particular attitude, how else are you going to ask them? But say, do you agree with this? Do you not agree with this? There's not a good way to measure that aside from this kind of scale. So it's a reasonable scale for the kind of thing they're measuring. But the thing that really jumps out at me with regard to this is this right here. What is that?
A citation.
It's a citation. That citation tells us two important things. The first thing is that these 30 positively and negatively keyed statements on a 7-point scale are previously published. That means that they've already been peer-reviewed and people in the field have already said they're reasonable questions for doing this kind of thing. That's the first thing about it that I know from reading that citation. The fact that these are previously published materials means there's a good relationship, or potentially a good relationship, between the data gathered in this study and data that have already been published. And we like that. We want there to be connections. We want people to use similar measures across studies so that we can compare the results and know that they connect. So that's good. The other thing this citation tells me, Sizemore and Lewandowski. Let's go back and look at the authors of this paper. Sciarrocco, Lewandowski, and Van Volkum. So now we know two more things, which is that, one, the second author on this paper has previously published research in this area, which means they probably know a good bit about it. This is probably something that they're interested in doing, and this is maybe an area of expertise for them, so that's good. But we also know that the researchers in the current study are using materials written by the second author, and there may be some bias about using those materials because they're his. So there might be better materials out there, but they didn't use them because they're not his. Right? So you can invent your own measures and then keep using them over and over, even if they're not good. Just because you wrote them and they were peer-reviewed and published doesn't mean they're the best measures out there. It just means that they're adequate. So there's some clue that the people who are doing this study have some degree of expertise, or at least have some experience doing this kind of thing, asking these kinds of questions and evaluating these kind of things, so that's great. But we also might have some concern about the bias, about the questions that they used. Maybe they're the best ones, maybe they're not. But definitely this researcher is invested in this particular topic more than others might be. So those are the things that I see when I look at that. What kind of scales are the dependent variables measured on? And are they the right kinds of scales to use given the kind of data they're gathering? What do you think? What kind of scales?
Self-assessment.
It's
Self-assessment.
It's self-assessment. Do you know what those kind of scales are called when we have a strongly agree, Likert scale? Right, this is a Likert scale. And how would we categorize a Likert scale using the different types of measures we've talked about in 3510 and 3530? Is it a nominal, ordinal, interval, or ratio scale? Is it ordinal? Is it nominal? Is it interval? Well, let's see. We've hit almost all of them now. Is it ratio? Okay, good. Is it? We don't know. We always ask all of them. So what would it be? So let's think about what the different kinds of scales are. So nominal means it's just categories with no order. Ordinal means it's categories plus order. Interval means that it's categories plus order, and the units are something that we know how much it is. It's a fixed unit, like a degree or a pound or an inch. Okay, so we know it's a fixed unit. And ratio is all of those things plus 0 means truly 0. Ordinal. Okay, so these are ordinal scales. Okay, they have order and categories, right? But one person strongly agree might be another person's just plain agree, right? And the difference between strongly agree and agree isn't necessarily the same as the difference between agree and neutral, right? We don't know. So these are super squishy ordinal scales. They are not interval scales. But what they've done is they've assigned a number to each one of the categories, right? Where strongly agree is 7 and strongly disagree is 1. And then what do? They do t-tests on those numbers, okay? Those aren't real numbers. Those are just category markers, right? The 7 on those scales doesn't really mean 7 things. It just means the highest ranking thing on an ordinal scale. So they're doing t-tests on what is truly ordinal data. And that means that these numbers are really, really hard to interpret because they don't really mean anything numerical. They just mean kind of rough categories. So if you see a score on there that's like 5.04, well, all that means is that the average was around a 5 on that 7-point scale, and we don't even know, so that's what? Strongly agree, mostly agree, somewhat agree. Like, what is it? So it's like maybe people agree. Okay, they agree in a very nebulous and smushy way. All right, they agree. Okay. But so, right? I mean, so it's not like, it doesn't, well, the average was 5. All that means is that people typically agree. Okay, but it somehow sounds more scientific if you say it's a 5 than if you just, because you can't do math on Okay, I take 5 strongly agrees and 2 agrees and 6 strongly disagrees, and I take the average. Like, what's the average of that? Neutral, you know, or what? Like, what is it? So it's they're doing inferential statistics that were designed for interval and ratio scales on ordinal data. Now, this is really common in these kind of studies. So when you're asking people about their beliefs and attitudes, there's nothing else, there's no other way to ask them, right? There's no way to quantify someone's belief. There's not like belief units or attitude units that we can count. There is no other way to ask except to ask them these ordinal questions. And so they're doing, this is very typical, but just be aware that the math they're doing is some of that squishy hand-waving statistics that happens in social sciences that makes people in the hard sciences go, this isn't really science. Because you're taking the average of people's attitudes. What does that mean? What's an average attitude? So just so you know, here it is. It's happening. It's totally normal, but that's the issue. Okay, so the researchers use RES, a version of the Pearson's correlation coefficient, as a measure of the effect size in this study. For this measure, small effects begin at 0.1, medium effects begin at 0.3, and large effects begin at 0.5. Anything below 0.1 is considered negligible. For each of the dependent variables listed below, indicate which group, experimental control, had a numerically higher score, whether the p-level was statistically significant, and what the size of the treatment effect was. Okay, so what'd you guys find? In every case, which group had the higher mean? The experimental group. Okay, in every case, the experimental group had the higher mean. Okay, in which cases was the p significant given an alpha of 0.05?
Research perceived utility.
Okay, research perceived utility. What else? APA style efficacy. Statistics, attitudes. Add skills and abilities. Yep, when you scroll down here, there's the table. Okay, so this one is significant, this one is not, this one is not, this one is, this one is, this one is, and this one is, right? So the critical thing is here in this column, the p-value needs to be less than 0.05 for it to be significant. Did everybody get that? Yeah. You able to read the table? Okay. So now if we look over here, let's go down and say whether this is a small, medium, or large effect, given the rules for this type of measure of effect size. Okay, it's a little bit different than the ones we've used before. So is that a small, medium, or large effect?
Small.
Small. What about this one? Small. This one?
Negligible.
That's negligible, right? That's not even, it doesn't even count. There's like nothing there. Okay. What about this one? Medium. Small. Small. Medium. Okay. So we have all small and medium effect sizes here in terms of changes in attitudes. So all small and medium effects, except for this one negligible effect. Like that one, they're saying basically there is no difference at all between these groups. This had no, whatever we did had no impact on people's attitudes about their research skills and abilities. That's not very good, actually, if you think about it. Either this was a research methods course that was all about helping them develop skills and abilities, and the one case where they got no effect and no of the effect size that was negligible was research their students' attitudes about their research skills and abilities. Oops. That didn't go very well. Okay, so how do we feel about these statistics? Do they make sense when we think about what was significant in the effect size? Are there any cases where we got a medium or large effect but no significant result? No. That didn't happen. Are there any cases, so that's important because if we ever saw a medium or large effect and they reported no significant result, I would be like, what? Because that doesn't match, right? When you have a large effect size, you're much more likely to get a significant result. It's really weird if you have a large effect size and you don't get statistical significance. So if you ever see that combination, alarm bells should be going off. Because if they say there was no significant difference, but it was a large treatment effect, you should be thinking, this is a type 2 error. They've missed something here. There's something wrong with their statistical analysis. So if there's a mismatch between the effect size and the significance, alarm bells should go off. That tells you there's something wrong with their statistics. Now, medium effects then, they're less likely to give us a significant result than a large effect, but still medium effects are pretty important. Are there any cases here where we have, we've got effects where it's significant but the effect is small?
Yes.
Yes, we do have some cases where we get statistical significance but the effect is small. So that would be where? Here, right? And here, right? We got significance but the effect is small. In these cases, you might be thinking, wait, okay, that's a small effect. That means that it's not really very important, kind of, right? It's a small treatment effect. They're getting statistical significance. Is there a chance that this is type 1 error? Could they be finding a difference where 1 doesn't really exist? And what you want to think about at that point is, well, let me think about their sample sizes. Were their sample sizes big enough that it seems reasonable to me that they could have gotten a significant result, even though the effect size was very small? And the typical cutoff, the one I want you to use in your mind for this, is were their samples at least size 30? And in this case, they had one sample that I think was 32 people and one sample that was 37 people. So in this case, they had samples that were reasonably large, and even though their effect sizes were small, that those large samples helped them get a statistically significant result. So I'm okay. Even though those are small effects, I'm not too worried that those are type 1 errors. But under other circumstances, if I saw a small effect and statistical significance, I'd be really curious to look at the sample size to make sure I believed that they weren't committing a type 1 error. And that's important because we might look at other papers where they have some issues with the statistics, and that matters, because if people are doing funky statistics, well, that's a problem if they're publishing weird stats, right? Because people already have an issue trusting statistics, right? Why? Because they say you can lie with statistics really easily. So we have to be thoughtful about whether the statistics make sense and whether we believe the results that they're reporting show real findings that would replicate in the real world. And they're not just some fancy pants math thing they did for the purposes of getting an article published, because it will look good. So I'm okay. I think this looks all right. Let's talk about the generalizability of the study's findings. How represented do you think the sample is with respect to psychology graduate students? Undergraduate students. You guys are psychology undergraduate students. How much do you think these guys represent you? Okay, so you think it's pretty representative. The age seems about right. The year, juniors, seniors who would be taking this class. Okay?
I felt like they should use at least another school, not just one university.
Okay.
Like it'll make me feel like I trust it a little more.
Okay, so the school that they used is a medium-sized private liberal arts school.
Yeah. Like,
Right? Now, who goes to a medium-sized private liberal arts school in the northeastern United States?
Right. Really smart, rich people.
Smart, maybe.
Yeah, I didn't want to say that.
White,
True.
affluent,
Yeah.
huh? Probably affluent. Well, I mean,
Yeah.
Spelman's a private school too. Do you have to be rich to go to Spelman?
Yeah.
It helps.
You got no scholarship. You here.
Well, but the same thing would be true there, right? People could be going on scholarship too. I mean, my niece goes to fancy pants liberal arts college in Minnesota, and I can tell you, there ain't no way her mom, who's a professor like me, would be able to pay if she hadn't gotten a scholarship, right? We're not
I
loaded.
feel like she's more ambitious than those who didn't apply for scholarships.
Maybe, right? So so it could be that these are real go-getter students working really hard. I don't know. But you know what? I wouldn't say that just because you guys are going to a, urban research university, you're any less of a go-getter or working any less hard.
It's more diversity here, though.
Probably a lot more diversity here. You're right. Now, diversity in terms of maybe socioeconomic background, diversity in terms of racial and ethnic background, maybe diversity in terms of religious background, right? Those things could all be true. Typically, yeah, I mean, my guess would be that school is probably looking pretty white, pretty wealthy, right, for the most part. That would be my guess. But here's my question. Do you think that being white and wealthier influences how people respond in a classroom about experimental design? Do you think that's going to change how they react? You're like, I don't know. Having not been white and wealthy in my life, I'm not sure. Or maybe you do identify as white and wealthy. I don't know. I'm not going to make judgments for you about your racial identity, your socioeconomic status. Maybe you are white and wealthy.
I mean, I guess put in that. So this was like I feel like it would have been more trustworthy if they used another school also, not just the one.
So. Right, but it's true that lots of studies that happen at universities, they just do them at the school where they are, right?
Yeah.
But if we tried to replicate something like this at Georgia State, do you think it would work?
Yeah.
You think so? I mean, that's a question.
As far as the psychology of the graduates concerned, yeah, but as far as like in general, I don't think it really will work just because of, I don't know.
Well, that's the question we have to ask. So we talk about psychology. Who do you think they're trying to generalize to? This is published in the journal Teaching of Psychology. Who are they trying to reach? Psychology teachers, right? They're trying to help psych students learn this stuff. Do you think that psych students at different kinds of schools, so from this medium-sized liberal arts university to, where the classes have 10 students each? When's the last time you had a class with 10 students in it? Here. Preschool, right. That doesn't happen much here, right? But what if, one thing I can imagine is that maybe something like this very elaborate, let's all work on projects things might be harder to do in a larger class. I mean, how many times have you gotten stuck in group work where you're like, you got stuck with the group from HE double hockey sticks? You're just like, all the time, where it's like, oh look, I'm in a group of 5 people and I'm the only one who ever does anything, right? Whereas when you're in a class with like 10 people and you're in a small program where maybe there might be 100 undergrads, we have like 2,000. Right? Can you imagine at that small school, people might be, maybe it's easier to do the kind of group work that would be necessary in the experimental group, maybe? Possible. So it could be challenging to do in another setting if the classes were really big, if you didn't have enough TAs and things like that. That might make it hard. We also might have more variation in ability and interest, right? You think about the range of people. We've got people who are going to that small liberal arts school or medium-sized liberal arts school. Many more of them might have parents who have a lot of education. They might have gone to elite high schools, elite junior high schools, elite elementary schools, have lots of experience with all different kinds of teaching styles and different things. Whereas if somebody was like straight up public school in large classes all the way up, what are they used to? That more traditional approach. You get to this place, it's like, okay, everybody, you're going to teach yourselves! And they're just like, like, what are you talking about? What are you're not teaching me in any way I've ever been taught before, and maybe I'll respond really well to it, but it might also take me some time to get used to that, and by the time I get caught up, it might be halfway through the semester, right? So, again, these are just some things to think about. So your point about them doing it in more places, in more types of university settings, I think is really important. In order to understand whether this would truly generalize across to different kinds of schools, we need to try it in different settings and see if it would work, or if it's really something that works best in these smaller settings with roughly 10 students per class. I'm trying to imagine teaching this class with 10 students per semester. That would be strange.
At least everybody
Yeah.
Huh?
I said, at least you know everybody by name.
Well, yeah, that's true. But I mean, we do pretty well in here. We're a good group. I like my team. I like my class. My class usually like me too, so we're set okay. All right. How are we doing? One more question. Okay, so we talked about the limitations of the study. Okay, we talked about the issue of not being able to do random assignment. Let's talk real quickly about where they said, the researchers combined scaffolding with several active learning activities in the experimental condition. Why do you think they did so many different things all at once, and what might the costs and benefits of this be? Yeah.
Well, I have a question.
Yeah.
What's pedagogical?
Pedagogical?
Oh, okay.
Pedagogical means teaching. It's a fancy pants way of saying teaching.
I had to Google it, don't worry.
Well, see, learn the word. Increase your vocabulary. Pedagogical means teaching. So when a study's about pedagogy, it means it's about how to teach. The study of teaching. I know it seems kind of weird to talk about the study of teaching, but yeah, we have one. So they combined several different activities all at once. Right? So the difference between the experimental group and the control group was huge, right? In terms of what the teachers actually did. Based on what it says in the article, the students in the experimental group didn't get a chapter assigned to read. They read an article instead. Then they started summarizing the article and critiquing it. Then they did experiments. Then they designed experiments. There was no lecture, right? So they never got any overt instruction about the stuff beyond that interactive type of instruction. So there was no, okay, let's talk about concepts and make sure everybody knows what we're talking about, whatever, that kind of
So
stuff.
there was no basic. Well, my thing is, as far as the cost, was there any type of background other than them getting the article, like, hey, you're going to give us the article, you're going to read this, and I'm going to ask you these questions about the variables, whatever. But there was no background.
The article doesn't say